mostly lately focused on the networking part of the OpenStack, which is Node 1. I've understood here that there will be a lot of most of the people who are presented are developers, web developers, so you are more inclined to the beautiful. Please excuse my slides are made by sysadmin. I like beauty, but I'm not so good at creating them. We thought about this OpenStack presentation to offer a general overview about what it is, how it can be used, and we thought that the best way to do this is by sharing the experience of someone who started using it and how it used it and how it improved its workflow and what were the advantage that he saw using it. So this is why the name is OpenStack my way. My grandfather was a ranger. He was taking care of the forest, and when I was a kid I remember that I always was surprised how big the logs in his wagon were. And he was alone in the forest, and I said, "Hey grandpa, but how can you do this? You alone there?" And he said, "Oh, I have a good friend." And I said, who is this friend? Who? And it's the need. And I said, I was believing because I was a small kid. I said, "And how do you do?" I go there and I said, "Okay, need, come and help me." And I stay. The need comes after 2 hours, and then I carry the wagon. So I observed that in my environment, OpenStack started in the same way. I had a need. I worked as a quality assurance engineer for over 6 years, and the company for which I worked was called Ixia. I don't know if you know about it. It's a company which creates network testing equipment, so generates a lot of traffic in a very complex scenarios, routing protocols, HTTP load, FTP load, to put the network under heavy load and to see which are the limits. And most of the development was happening in Windows, so the application, part of the application that with which the user was interacting was in Windows. And for example, when I went first in the company, I think the QR drop, which was released twice a week, was around 500 meg. When I left after 6 years, I arrived at 2 gig. So you have to install twice a week 2 gig of packages, and next Windows, and then after the drop was not useful anymore, you have to uninstall everything and then to install. And I said, come on, it's too much. I can't handle any more of this repetitive task, so I have to find a better solution. And I begin to investigate in the virtualization area. I begin to look at the virtualization. At the beginning we started slowly with VMware player. We were exchanging these machines between us, and one engineer was installing all the versions, then another one was copying, so still wasn't so good, but anyway. Then we said, okay, maybe we need something that we put a lot of servers together, and then we have like something like a management on top of them, and we manage them as a entire block. And we found at one moment Oracle VM, I think it was version 2, when we started to investigate it. It worked quite well. It was based on Xen hypervisor. But once we had a power loss in the lab, and because some file system from Oracle which was inside of the solution, it was proprietary, very difficult to debug. We didn't know how to do it. We spent a lot of time and said, no, we have to choose something which is really open, so we can, I don't know, ask community, see what's happening. Maybe we had also a big development there. Maybe we can ask some developers if they can look, but we don't see. Then we started to look at VMware 6 3.5. I remember that moment. This is the time frame of 2010, something like that, 2010 2011. That moment 6 3.5 it was free, but you could use maximum of 60 gig per server, and I think just one CPU socket. And it had the problem that every server was separated. So either you buy the vSphere license that manage everything from one place, or either you have to go to each server and do stuff. And then for a period of time, I think one year, something like that, we settled with Proxmox, which is a German virtualization solution. It worked quite well, but the idea was that it wasn't really a cloud. It was something like management, virtualization management. So you have 3 servers, then you have web interface, go there, spawn templates, machine instances, stop them, but you can't spawn multiple of them, you can't throw them away very easily. So it's like was like VMware player, but from which you can manage multiple physical servers from the same web interface. Then we had a little more small investigation in Cloudstack. At the beginning was at that moment was it belonged to Cloud.com. It wasn't open source, and if you wanted to run Windows machine, you had to pay license. It was the same with Eucalyptus. As we had a lot of Windows machine in our environment, this was a limitation for us, and then we found OpenStack, which was completely open. This was probably the main point which attracted me. It was you had access to everything, whatever KVM supported, OpenStack can run. Documentation was there. It wasn't so good, but anyway, we started with the Diablo release. Then we upgraded to Essex, and from there on we keep using it in the company for which I worked at that moment. Then I understood that as a quality assurance engineer that now we got in something different than virtualization, because I understood that now it's a different way of seeing machines. It was like till now we thought of the machines like physical machines that you have to take care, you have to install, you have to patch. And then I understood that the machines were like napkins. So you put a drop on it, you use it, then you throw away. You don't have to uninstall anything, you don't have to clear, you don't have to do anything. I don't know if you heard about this comparison in cloud computing, I don't know, discussion between kettles and pets. That somebody started to talk in this cloud computing environment, like at the beginning you have virtualization, you have your Microsoft Exchange server, you have to take care of it, it has a nice name, you have to patch it, you have to, if that goes down then everybody is scared and things like that. Now you go in the direction which doesn't matter. So you have, I don't know, cow 01, cow 02, cow 03, cow 89 is down, okay, spawn another cow. So it's, and it was the same in our case, so I understood now that something is different. And in this cloud computing, I think to clarify a little the concepts which are vehiculated in this regard is that you have 3 main terms which refers to cloud computing. One is infrastructure as a service. It's what VMware, Amazon AWS, Rackspace, Google Compute provides. You have platform as a service, which Cloud Foundry, OpenShift, Google App Engine, Heroku provides, and then you have software as a service, like Google Analytics, Salesforce. I don't know if you know the story about how Amazon AWS was born, how it appeared. The idea was that Amazon had, because of the shopping seasons, which is Christmas and Black Friday, they need a lot of resources to be able to handle all this traffic generated by this shopping, and they had they built huge data center, and then after this season passed, this computing resources was not used anymore, and an engineer in South Africa said, "Oh, come on, but why don't we make something like an API?" And we ran them. And at the beginning, the CEO of the company said, "Okay, now you have to write me a press release, how it should appear in, let's see, 1 year or something like that. You write the press release, and then I will try to push the idea, I will try to offer you all the resources." And then he had to fight a lot with the board of Amazon because they were against the idea, saying that we are in a different business, we sell stuff, we don't sell computing. And Jeff Bezos insisted, no, we have to do this. And so a new industry was born from an idea of engineer who it wasn't a, I don't know, a architect or something like that. It was just an engineer that came with the idea and then generated a big multi-billion industry. And to illustrate in the picture what are the differences between those three types of terms of cloud computing is that when you have the solution when you have all on-premise data center, and then you have to take care of everything. So you are responsible for everything that is there. You have infrastructure as service, in which you take care, or you are responsible on what happens on top of the running machines. If those are provided to you by the provider. Then you have platform as a service, as I said, like Heroku, Google app is doing that. You have a platform where you push your code and then it is run there and scaled and they take care of everything. Or you have a software as a service where you have just a login and a password and you don't care of anything else. In this respect, OpenStack it provides infrastructure as a service, and it was founded by Rackspace Hosting and NSA, and no,
that's NASA.
NASA, sorry, but NSA is a big contributor.
Yeah,
we don't know why, but NASA, yeah, and. How they define OpenStack, they say that it's a standard and massively scalable open source cloud operating system. They say that it's like Linux of the cloud.
But maybe what is interesting to know is that when Rackspace and NASA start to work together, they wanted to build a platform as a service initially. But they said like, okay, but we don't have a layer below. That is why the OpenStack was created. Okay.
And now users of the software are Rackspace, CERN, which is the big physics research center, Cisco, WebEx, BMW, Walmart announced recently that they are starting to invest in OpenStack and to use it. Mercado Libre, which is like eBay for the South America, they said that there are like, I don't know, they have like 60 million users or something like that. eBay with PayPal and NASA. OpenStack now, it's not, at the beginning was managed by, all the development was managed by Rackspace. Now it was a foundation created. They said it's the second open source foundation as a budget after Linux Foundation, like talking about something like $10 million yearly, and this foundation is managing now all the projects. And in the foundation there are like platinum members, AT&T, Ubuntu, HP, IBM, Rackspace, Red Hat, SUSE. Now there is the biggest contribution are made by Red Hat and HP, and each of them it's gaining the I would say the title of the biggest contributor depending on the moment in which you are looking. So they are pushing a lot. gold members, Cisco, cloud scaling, Dell DreamHost, Innovance, which was bought by Red Hat, Intel, Mirantis, and a lot of others which are not added here. What are the components? So the idea of the OpenStack was that when you need computing resources, practically you need compute, you need network, you need storage. They split the computer from as an abstractional level, and then all these components should talk.
Liebe Leserinnen und Leser, die Ausleihe schließt in 30 Minuten. Wenn Sie noch Medien außer Haus entleihen möchten, erledigen Sie das bitte in den nächsten Minuten. Magazinbestände, die Sie heute nicht mehr benötigen, bitten wir abzugeben. Ladies and gentlemen, the circulation desk will close in 30 minutes. If you would like to borrow any library materials, please do so now. We also kindly ask you to return no longer needed library materials.
Thank you. And so they split all these components, and then they talk between them via the APIs to, and how it looks like. The communication, it is pretty complex. At the beginning it has difficult to set up and to install everything. Now after, I don't know, several years, you can start you can start much more easier to have such a deployment or something like that. You have a lot of tools that can help you, but at the beginning, when you had to install the packages, make the configuration manually, each parameter has an influence on the other parameters which are on the other components, so it was not an easy job to do. You could make mistakes in a lot of places, and most of the time you make it. If somebody is interested, I don't know, about how you can install and things like that, we can also discuss in another meeting or you can ask me or something like that. What are the components? In a few words, it's compute, which provides CPU RAM resources. There is a service which belongs to this component, Nova, which communicate with the hypervisor via libvirt, and the hypervisor could be KVM, could be XAMPP, could be, now I saw also Solaris is supported, could be Windows 2012 Hyper-V. So you have a lot of options for the hypervisor that you want to use for the virtualization. Then the networking component is served by the Neutron. At the beginning it was called Quantum, but because of some legal issues, now it's called Neutron, and it provides ports, routers, switches. What it does practically, it allows you to create an overlay network over the physical network, so you can have the same IP addresses used by two different tenants on the same platform without having any issues, so without everything being handled via encapsulation. And this, all of this is taken care by Neutron. Then you have volumes, Cinder, which you can have disk attached to the machine, and this is served by Cinder. So here you have a lot of options what can be beneath of this as a physical space, as a software beneath this Cinder. You can have Ceph, you can have cluster FS, you have multiple options, and then you have also storage. Storage, when I'm saying storage, I'm thinking about object storage, so to like S3 buckets or things like that. These are those are the main components. Now the project is growing, so now you have also Heat, which is an orchestration engine. You can define an entire infrastructure with servers, DNS, DHCP, everything in one file, and then you can push this file in OpenStack, and then for you it creates everything: network, ports, machines, rules, firewall rules between them, and things like that. Also, you have Designate, which is a project which offers name resolution. So it grows. New and new components are added always. And also you have dashboard. A dashboard is the web where you can access the infrastructure. And you have Glance, where you can keep a catalog of virtual disk image that you spawn, and you have also Keystone for authentication and authorization of the user, and also of authorization of what each service can do regarding to other services. This is how it looks. It's all the picture. I will also show you. I will try to make a live demo to spawn an instance from the new. This is how it looked when I was using. You see, we had a lot of images and snapshots, meaning each snapshot is a Windows machine that has a particular drop installed, and we had a history for this, so it was easy to reproduce stuff or to. This is how you look when you launch an instance. These were running instances, and this was a new Windows machine which was started. What was for us, for example, what was very surprising was that when we finished implemented it, it was really surprising how easy it was to have an environment comparing with what we had before. Because before you had to install, you have to ask another colleague, or if somebody else wanted to have a new machine, you had to request to the IT. Now it was very easy, because once one engineer has installed a drop, then all the QR, dev, everybody could have access and can do whatever it wants. What happened after was that we also automized the process, so every time when a mail with the new drop was sent, it was a script that was looking in the mail, then spawn an instance, took the drops, install them during the night, make a snapshot, so the next morning when you come in the office, you have everything installed without doing anything, and anybody had access to it. Then we had also we succeeded to have a history of all the drops, and every time when a customer had an issue with a particular drop, it was easy to start investigate. So, and also it was very important for the testing, because we had regression which were growing as a number of tests, as new features were added, regression was growing. And it was very easy now to, when we need the regression, to say, okay, this evening we'll use 100% of the capacity, and also we can go to over a cloud of another team to run our regression, and then the next day then can do the same on our environment. What happened for me, this was a start of a new career, because from there then I went to eCircle. Also creating a private cloud. eCircle is a company which is creating, it's sending mail, a lot of mail, so big customers go to them, give them database and say, okay, now I want to say that Happy Christmas, and we have a new BMV that you can buy, and they had now they are building a private cloud in which will be based on OpenStack. And then I have the Cloud&Heat, which was named before Aotera. Probably this was, maybe you know better, Aotera, because this was the name, first name here in Germany. Now they changed the name. And what is the masterpiece of Cloud&Heat is this rack that you have, you can have in your own basement. It's filled up with servers, on those servers OpenStack is running. When OpenStack is, or when compute resources are used, the heat generated by the servers are taken, putting in the tank, and then you can use it warm water for heating, for washing, so it's like at the boundary between two different markets: resident market, which needs warm in a green way, and server or computing market, which benefit a lot because you don't have to build anymore the space for your data center. You use the space which the resident provides, so you don't build it. It's there. You don't rent it, so everything is there, and the client pays just the price for one of those rack, and then he doesn't have to pay anything for the energy because the energy is paid by the user of the compute resources. And also it's distributed, so it's in a lot of towns in Germany, so you can't have, I don't know, data center fell down, it's down because something happened with ISP in that region. Maybe you have one of those rack down, but not the entire cloud. This is the address of the company if you want to know more. We have also very interesting tech blogs about how you can use and how you can spawn instances via the. I can open a web. I don't find the mouse. Okay. Come on. This is the, if you are interested more about, and what I was telling you about, it's techblog cloud&Heat.com. And here, for example, we have a very interesting blog written recently by one of our colleagues. I will make a live demo now, but it will be a minimal one. This is more advanced one. It's very interesting. I recommend you if you're interested to see how you do it. Also interesting, it's the OpenStack. This is practically the homepage of the project. There will be a summit. There is a summit each 3 months, each 6 months. The last one was in Paris. The next one will be in Vancouver. We have also a session there. Okay. And now I want to F5 again. F5. Oh no. Okay, so this is my grandfather. Okay. Things change. This is the URL. And now how you can spawn an instance. I will spawn an instance via the dashboard. There are multiple ways, but I will show you 3 ways this evening. And it remains like an open discussion if you want to see some other ways. I think probably the most interesting one will be via heat, if we go deeper, or via, I don't know, chef or something like that, to have everything deployed there. And so let's go, and I'll go to demo. This is the dashboard which was mentioned in the slides. This is what you see as a client.
Is this what comes with OpenStack, or is that what you did?
We customize the layout, so normally it's not green like that. It's more I think Ubuntu has orange, red hat. It's more transparent, so everybody SUSE it makes stronger green. So, but this is the logic is the same. So this is what you
can quite easily customize the left panel, upper panels. Everything is Django based, so it's quite easy to customize. So depends on the company. We also inject our own panels as well for different products.
For example, here I have a button which is instances. This shows which are the running instances in my deployment. In my tenant, I have an instance running, has an IP address, an internal IP address, has a size, meaning what is the RAM, what processor is created with, which is the ephemeral disk, the key pack that was injected, the fact the machine is active, it's running, since where it's running, and some actions that I can do on the machine. So this is, I can snapshot it too.
And click also on the machine.
What?
And click also on the machine, show what is that. Yeah.
Yeah, if I click on the machine, I see the log of what happened when the machine started. I have the console. Here I can log in, or I can but I will log in via SSH because it's enabled just via key, so I don't have a password for the user.
Access information.
Access. Yeah. This is a slightly modified deployment of us, because the normal deployment here SSH will have a method to access the machine via forwarder or something like that. But we can access it directly via public IP address. Okay. This is where you can create volumes and then you can attach to the machine. The idea of the volume is that they are high available, so they have beneath a cluster-FS, and which is spawned on multiple servers inside of one rack. So if one of the machines goes down, what is on the volume won't disappear. The machine itself, it's just has a ephemeral disk which is physically located on a physical server on a host. So if that host goes down, the machine will go down too. Here there are snapshots that you made, or the public images that you can spawn. So these are the templates that you can spawn. You can create your own templates, customize. Here you have firewall rules that you can say which ports are open from where. Here you can define the key pairs that will be injected in the machine. You have the floating IP that you can use, and here are the API endpoint with which you can communicate. It is you can also write your own application because it's RESTful API. So I think there are implementation for Python. I saw something for PHP, and I don't know exactly, but it is written in documentation of OpenStack.
Those are the Amazon terms. Is it eucalyptus running?
What?
These are the Amazon terms like S3, EC2, and so on. Is eucalyptus running on that so that it emulates the API, or?
No, OpenStack itself supports also Amazon.
So it's binary protocol compatible.
Amazon API, yeah, not 100%,
okay,
but like 80% it supports. So you can if you want to use the API, then you can use the Amazon commands. This is the network. This is the layout. So you see, I have public network. Here I have a router created, and here is my machine, which is behind this router. At the level of the router, there is a mapping between my public IP that is allocated to the machine and the IP, private IP of the instance inside. I told you here I can create, I don't know, I can create my own network, so I have 192.168.1, another tenant can have the same IPs without any problem, so everything will be tunneled.
And the router lives in a software?
The router is with the default neutron, the router is a namespace.
Okay.
IP namespace on one of the hosts. There is a service which creates it, and inside of that namespace everything happens at the level of nothing or
Liebe Leserinnen und
fireball
Leser,
and
die Ausleihe schließt in 10 Minuten. Wenn Sie noch Medien außer Haus entleihen möchten, erledigen Sie das bitte jetzt. Magazinbestände, die Sie heute nicht mehr benötigen, bitten wir in den nächsten Minuten anzugeben.
The router itself was one
Ladies and
interface
gentlemen,
in the
the
public
circulation
space
desk will
and one
close in 10
inside.
minutes. If you would like to borrow any library materials, please do so now.
Okay, so
We
now
also kindly ask you to return no longer needed library materials.
let's first, I will first create myself a floating API address. Allocate floating API address. Allocate. Now I will spawn an instance via the web. I will say launch instance. I will put demo 01. This is where I select how much RAM or how much virtual CPU the machine can have. If you see, I have 2 vCPUs, 4 GB of RAM, XS which is 2 GB of RAM, the maximum I think 60 GB of RAM. And then I can specify how many machines I want to be spawned. Then I can select an image from where I can spawn a machine. And I will choose this one. Then I will push inside this key. I will choose a network port for this machine. Here it's very interesting. It's post creation. Here I can even run a bash script after the machine will be spawned, or either I can use a component which is in the template itself called Cloud&Heat, and on this Cloud&Heat I can make a lot of customization. Like for example, I can install packages. I will show you in the model of my codecs. Yeah, I can upgrade the machines. If I'm specifying in this format packages ggcc, these packages which are specified after the line will be installed. Then I can also copy directly files inside of the machine. I can run commands, arbitrarily commands. So everything I can do it here. If you are more interested, you look at the blog post which explained very detailed. Or I think there is also Cloud. And here is everything detailed. You can do a lot of stuff. Okay, I will launch the instance. Now, as a little overview, what happens now? The API calls a component called Nova Scheduler, which looks at all the hypervisors that are beneath of this, because behind of this are like 20 servers, I think, this deployment, and it looks and see which one is freer as a space, or who has more capacity, or RAM or CPU, and then choose that one. Everything happens via RabbitMQ, all the communication, and then say, okay, which one has the most capability, the most resources I have. Okay, I will spawn on you, take the image which is in glance, copy there. If it's in a QCOW format, transform it in raw on the disk of the server itself, and then push all the data that the user asked for inside of the machine, make all the customization and things like that, and then say, okay, this is your machine. Create the ports, create the tunnels, create. So this is what's happening beneath now.
Do the images already live on the rack, or are they downloaded from a cloud server?
No, they are already there.
Okay, so all of the images available are synchronized across all racks.
We don't do this automatically now. I think we have some scripts that the images are taken from the Ubuntu, from the Debian, because they offer those images, and we take them from time to time, and we push them in our racks.
Does it work if you create your own image, or do you distribute this one?
You can create your own image.
Yeah, if I want to spawn this then on another rack, then I have to migrate it to another rack image.
Yeah, if, for example, I will explain a little what are the concept that how we are using, what we are referring when we are talking about a deployment in Cloud&Heat. A deployment can be starting from 1 rack to 20 racks. So for example, if you have a big hotel or a big office building or something, you can have 20 racks. And these 20 racks, it's one deployment. So all the images are available to that. This is a location. Yeah, this is a physical location. So you can have a small house where you have just 1 rack. And if you have your image in a deployment with 20 racks, then your image is available there. If you want to spawn this image to another rack, then you have to copy to the different location. So it's not something that automatically transfer the images from one side to the other.
One more question to spawning the instance itself. You selected stuff like CPU and memory.
Yeah.
Is there any meaning of determining how much performance the CPU can provide in terms of it's a big CPU, is it Xeon, or it's just an AMD something, or is it standardized through all racks? It's basically the same CPU.
For example, we use something like CPU shacks, in which if a physical server it's not under heavy utilization and you have just one instance from there, then the instance will use, if it has one CPU, will use 100% of one CPU if it does a lot of stuff. But if then there are concurrent work, if there are if there are different tenants that have different machines on that, then you have a mechanism in which you say if you spawn a bigger flavor, then you have more vCPU shares, so you have more, a bigger priority.
Okay, but I can't have some certain type of CPU guaranteed, as in if my application has some certain needs in terms of CPU.
I don't know to tell you.
Okay.
This, if you want, I can ask.
Just curious
to my company.
Have you also kind of infrastructure overview where you can see all these storage stuff and the hypervisors?
Yeah, we have. Yeah.
But you can't show us.
I don't know. I didn't ask the permission. I would also being filmed. I
Can turn off the camera.
So this is a user interface and not the admin interface.
Yeah.
Okay.
But the admin interface is not much different than the admin interface of the OpenStack is not much more different than this. So you have I think 3-4 more buttons than this. But when you ask me, I thought about something like monitoring, in which I have all the machines, all the space. There we have all the information. It's not provided by OpenStack by itself.
The configuration stuff, where can I configure all this stuff? Or do we have to write in files?
This is handled in our case by Chef. So we have recipes that.
But to set up an infrastructure, so if you would like to something like that for your own application, so you need to write something like that in Chef, Salt, Puppet, or to use Heat. With Heat templates you will get some part of that, but not so much flexibility as with a configuration management system.
But I think I got in a way your question is, for example, if I could have a dashboard for which I see all my physical nodes and what's happening, what role each of them has. Yeah, there is something like that. It's called Fuel, for example, or SUSE Studio, in which you spawn a server which is a master. You have an ISO. You spawn it as server, and then all the other hosts that will host the virtualization or will provide the resources register themselves via PXE booting to this machine. Then there is a minimal operating system on them which will probe them for the hard disk, for the network, and then you decide, okay, I want this disk to be half Ceph, half Swift, I want this disk on this machine to be, and then you have on your dashboard, you have all your physical servers, each with what node, what role is allocated to it, and what resources it has. So there is something like I told you Mirantis as a, but we didn't deploy like this. If you go to mirantis.com, you have to register to their site. It's free, and then you can download the ISO image, which you can spawn in the virtual environment. Also, they provide some Vagrant scripts that you can. Oh, the beginning wasn't so red. So this is from here. Okay, so I spawned the instance. The keys are pushed inside. Now I will allocate a public IP address, and I will try to connect to the machine. From here I say more associate floating IP. I select one of the public IP addresses which are available. I will select this one. 237.23. And then am I inside of the machine? This is one of the way of starting a resource, a kettle or the infrastructure. I will show you the other way. Is via API command. I will show you a very simple API command. Let's delete this one. Yeah, so here I can shut down, I can snapshot it, I can delete it, I can terminate instance. And now it's deleting. And now I will spawn one via API. Okay, I'm on the machine, on this machine. And here I install the Python client API. The Python client API can be called from bash commands, or can be called Here I see I can interrogate. These like AC2 comments. Nova. This is the Nova list shows me the servers which are running now under my tenant. This shows me the template that I can spawn. This shows me the flavor that I can use to spawn instances. Also, it has very nice. It has also a Python, a native Python API, so you can go inside of a Python script, and you can do and offer. From my perspective, offers more possibilities because you have access to a high level data structure like list, dictionaries, and you can. It's much more easier to manage the infrastructure from inside Python than from Bash because you don't have to make a lot of grep and awk and.
Can you make the font a little bit bigger?
Yeah, but I will try. Zoom in, no? So the password can be seen.
Awesome. Thank you.
Okay, so now, for example, I will try to boot from yes.
What's the cluster parameter for?
It's the name.
Okay.
Name instance, I can specify the number. And now my machines are scheduled to be spawned.
So in this call we tried to spawn 2 machines. And there was a parameter number of instances.
Yeah, it was, I forgot to mention. So here it's simple. You specify the name of the image, the flavor, how many instances you want to spawn, and the name that you want the instance to have. And here, for example, if we make a Nova help boot, you can also customize it a lot, like saying what port do you want to add, if you want to have something like Cloud&Heat inside of the machine, if you want to have a key inside of the machine, if you want to have a volume attached from the beginning. You can also boot from volumes. For example, now I showed just how it is to boot from images, but you have the possibility to boot also from volumes. OpenStack offers. I think we don't support, but Openstack offers this possibility. For example, it was very interesting in one of the companies that I worked that we were booting from volumes because we were using Ceph cluster beneath of the volume, and that it is copy and write. The machines were coming up instantly because they were all reading from the same space, and then they were saying they were examining the space in the cluster, and they were consuming it when you do something with the machine. In this case, if you boot from the image should be copied from the repository on the hypervisor. Okay, let's see. And now our instances are up. So this is another possibility to spawn via the API. And there is another one which I like. For example, it's just an example. I'm a fan of Salt Stack, so I played around with it, and also with Salt Cloud, and you can spawn the instances via Salt Cloud. Oh, come on, help! I want history. And what will happen is that the machine will be spawned. The machine will be spawned, and then they will be configured they will be bootstrapped as a minion. So now I will show you. I'm spawning 3 machines. I will open a new tab. Here I have cloud providers defined. So here I'm defining from where I will receive these resources, these compute resources. I can have multiple. I can have Salt Cloud can use AWS, DigitalOcean. So I will show you that here. Okay. I will show you how it's configured here. Cloud. What? Yeah, but is the password for this event. So here those 3 machines that will be spawned will be automatically configured to connect to this master, Salt master. This is where I will authenticate myself. If I have multiple regions, I can specify here. Then this is the user that I use to connect to this project. This is the password for this project. This is the tenant name. This tenant name being the name of the project. This is the key that will be inserted in the machine itself. This is OpenStack. I can also specify here Rackspace, AWS, HP. This is where the key is located, and this is from where the machine will have IP addresses. Fixed IP means private IP address. Floating IP means the IP address that are public, the one that I can move from one machine to another machine. So this is where I'm defining where my resources will be. Then I have cloud profiles where I'm specifying cloud profile. Where I'm specifying, I'm giving labels named to association between a flavor and a snapshot. So I can have mixture between templates and flavors. I can here define another one, play 1G, which will be play 4G, which will be a flavor called STDS, where I'll have 4 gig of RAM, or I can choose another image. And then the final file where I make everything get up, it's cloud. And here I say, okay, I want to spawn me 3 machines called play 1, play 2, play 3. All of them will have to have resources which are specified in play 2 GB. It's the precedent file. And now what's happening here is the machine are spawned. Cloud Salt will connect to them. We'll install SaltStack minion on them. We'll start SaltStack minion on them. We'll push the key. So now if I go here, salt, let's see, master, no, salt, salt. Thing. Play one is already up ready and I can manage it from the master. So the other one are now in live. Probably if I go here on the web interface, I will see the other ones probably. The other ones. Yeah, so this was what I wanted to show for this evening. How do you find it? It was okay? It was not useful? If you think, for example, that you want to know more about certain stuff or something like that, we can discuss and we can organize something else. If you want to, I don't know, maybe you want to see how you could install it, how you can use heat, how you can create an entire environment from chef. We can also go a little deeper, or if you want to see, okay, I want to see how networking is working, what components are there, or something like that. I think we can arrange another.
Or like even like hands-on experience that we all sit together and starting machines, creating your own application environment into the Cloud&Heat.
Yeah, for example, I saw something interesting on the Rackspace site. They are using Heat templates, for example, to create a Glassstack server. Just copying, pasting to the OpenStack, and then they spawn 3 servers. Then using the Salt master, they install all the packages on the minion. Then they create the networks packages, make the synchronizations between the machine, decides which is the master, and then via IHA proxy. So this is like a complete stack that you can then use it.
When I just buy 20 servers, how do I get started?
What?
When I just buy 20 physical servers and want to now have my own private cloud in my company.
If, for example, if I will do like this now, I will start with Mirantis.
And what does Mirantis do?
Mirantis offer a CD, a ISO file. I think it's based on CentOS 7. Inside of it, it spawns some Docker instances. Each Docker instance plays a certain role, like PXR server, Puppet server. They have all the recipes inside, and then having this machine, you then put all your physical server to boot via PXR. You will see them all in a nice dashboard, and then you will decide, okay, I want this to be a controller, this to be a compute, this to be a storage.
But I would first still connect them to a router, so they all get their IP address, and then configure somewhere the IP.
They should be connected. No, I think the IP address will be received from this. So they need just level 2 connectivity. So they should be plugging a switch, and then from that dashboard you can decide based on the Mac. I want this machine to have IP addresses in those range, because the server which you start will function also as a DHCP server. So
okay. So just enter all the MAC addresses on which I want to install my cloud, and then the script takes off. And
it puts a minimal ISO. It probes all the components. It provides to the dashboard of Fuel. It provides all the information. Then you make the configuration via click, and then you say deploy. The machine will be rebooted, because you can choose also if you want to build OpenStack based on Ubuntu or Red Hat. They Fuel support both of them, and then the operating system will be booted, installed, and and then Puppet client will start, will take all the recipes from the Docker, from the server, and then we'll do all the stuff.
And then a hypervisor needs to be updated on one of the physical servers?
It will be done automatically because when the machine came up a few peaks, you will get everything from the servers. From the
Afterwards.
Afterwards, once it's all done and now security bug appears. And
I don't know exactly. For example, now we are doing I'm using Salt. My colleagues use Chef. Other colleagues will distribute Chef, but particularly executing commands on the servers, and then we do.
So there are many companies that provide this kind of installers. There's also SUSE, Red Hat, and they started already provide also this kind of patches. So you have this kind of special function where you just click and it's patch. And of course, you have to be aware of that this kind of more like the demo environment. So if you are a big company, probably you're going for somebody who knows how to do it. Because if you take a look on the OpenStack, you see it's all about huge API, which provide you everything. And it's also a huge opportunity for providers. So you have a company that provide virtualization, the hypervisors. You have somebody who is the business of management. So you see that it's not a complete product. It needs some additional stuff around it. That's why there are so many big companies, because they provide this additional stuff around the API.
Well, for example, a very interesting opportunity that, or I don't know, a very intriguing how you say action that VMware took. If you have vSphere license, something like that, they allow you, or they offer you an OpenStack inside of the an entire deployed OpenStack inside of the VMware.
You can also do it on Amazon, I think. Run an OpenStack.
Yeah, but what I'm saying is that VMware, if you have VMware, you can have OpenStack for free. It doesn't cost you anything, and they build it to be high available. So they have like a how you say, an architecture around it. So you have two controllers, two everything. So you just push a button, and then you have inside of vSphere you have 10 virtual machines which will offer you OpenStack, and then you can control your running machines either via vSphere, either if you want via APIs with OpenStack. So this is a very interesting approach for them. I think they want to fight back against Red Hat and everybody else, because vSphere was weak on this side of APIs and automation and things like that. So now they say, okay,
But you still need to install the vSphere on the machines, or?
No, you will have the hypervisors on the. You will have ASICs on the physical server.
So you were mentioning that the OpenStack API is only offering 80% of the functionality of AWS. So what are the 20% which OpenStack lacks?
I think you would need to take a look at the documentation. I cannot just say like that just fast. You just need to be aware that it's not top priority for the community currently, because there are two camps in the OpenStack. Of course, everybody would like to sell their own business, so this is the first priority. And it also define their approach to the legacy, let's call it legacy, because it's not legacy API of Amazon. So there are some companies which are trying to push into the mainstream, but somehow this camp is weaker than the camp which saying OpenStack API is the future. We should not put too many resources in Amazon EC2. So you might be surprised.
So there are two concurrent APIs in OpenStack, and probably the OpenStack API is developed further.
I think here, if you want to investigate more, the best way to go for it to study what HP is doing, because HP they have their solution based on OpenStack called HP Helion, and they bought Eucalyptus, and they integrated Eucalyptus, and the Eucalyptus was the private cloud solution that offered almost 100% compatibility with Amazon. So probably one of the main reasons why HP bought this is because they wanted also to offer to their customers this. I didn't study so much, but I think this was one of the
probably.
Does OpenStack have the possibility, like in EC2, to have an auto-scaling group with those launch configurations?
Yeah, via heat, yes.
Okay.
You can define alarms or something like that, and then if you pass over a threshold, then another instance will be spawned.
Okay. And it will be also added to the load balancer and everything.
Yeah.
How it works in EC2.
Yeah, something like that. Yeah.
At which size would you recommend going for a solution like this against something like Docker or Vagrant or something manually managed via scripts or stuff like this? How much would you say has the company or the scaling to be worth the effort?
I know. I think it depends a lot of what type of solution the company is providing. Because if the company has everything starts now and everything is web based and you can use Docker for everything, then probably Docker is the way. But if, for example, you have also some, I don't know, Windows, FreeBSD, different flavors that you still want to, or you have some security concerns, you can. I think this is a more tested approach and more.
So you can also make Vagrant to speak with OpenStack. So there's a plugin. And for me as a developer, from my own experience, is OpenStack provides a much higher performance. So as you can get from OpenStack as many concurrent test environment as you need. So this is a huge plus. And you can mix these approaches. So you can deploy your Docker images on the OpenStack. So I think this is the best mix because you can share the infrastructure among the developers, and especially in case of Vagrant, you don't need to share these huge images between each other. You can just say, log in on this and this machine. So you can it might speed up your development.
Or either there was an effort started, I don't know at what point it reached, that they want to have how you have as a hypervisor KVM, Xen, Hyper-V to have Docker also. So you can say, okay, these 5 images, my 5 images are Docker based. So you have one server of as many servers you want, and you spawn them, and they are Docker. I don't know, Docker instances inside of the OpenStack. How it is now, the machines running.
And what is also nice, if we are talking about development at OpenStack, it's really amazing to have OpenStack because when you have Jenkins, then Jenkins can share the same infrastructure with developers, and you can be always sure that you have a fresh Jenkins slave spawn on OpenStack, test around properly. The VM is going to be removed. If it's not properly, you come in the morning, you log on this machine, and you can debug it. So I was playing around a lot with Vagrant for testing and with using with other and Vagrant and Oracle VM, but I think the OpenStack was the easiest, fastest way of doing it.
So you were mentioning that the routing is implemented via namespaces. So I understand how it's worked if you are having like all machines on one hypervisor, but how is the routing handled when one tenant spreads over multiple hypervisor?
This is a normal case. The case with everything on one machine is not normal. So
okay.
How it's
then you would need kind of a router VM.
No, what is happening now? So the Neutron now it is a lot of development or a lot of solutions that appear near Neutron for the moment. What we have installed here and what I showed you is the vanilla one. So what it's come with OpenStack, and what happens beneath is that you have namespace. And then we can discuss, if we want to go deeper, we can discuss because it's a subject of another topic or a big topic.
You have tunnels between the hypervisors.
Yeah, but everything is managed via the Neutron. So, for example, what I can say, when the Nova API said, okay, I want a machine, then the Neutron said, I have to create for you a port. They decide, okay, on this physical host the machine will live, the instance will be created, and then okay, I need a port, then what happens, Neutron will go on that machine, and in a bridge which is configured, an OVS bridge or a Linux bridge, it creates you a port, then it creates you a tunnel to the machine on which the namespace which makes the routing.
Okay.
And everything you can have GRE tunnel, you can have VXLAN tunnel. So everything is encapsulated from one hypervisor to another hypervisor, but for the machine themselves, it's just like the package traversing.
So one hypervisor takes the routing role for that tenant or for that.
Exactly.
Yeah, and then all traffic will go through it.
Yeah, we'll go through it.
Mm.
Now this happened in the Havana, but now in the newest version like Kilo, you can have also this routing distributed. So you can have multiple hypervisors that take care of routing for one tenant.
Okay.
They make some synchronization at the NAT level of the output table between them or something like that. So this is also this is the vanilla approach, but then you have also companies that create a solution around this, like OpenContrail, which comes from Juniper, and they speak directly with the kernel OpenVSwitch kernel module, and they create the flow inside of the hosts, and then everything happens from the Linux, from the host, and then everything is distributed. You have Cassandra databases where everything is kept, and you have BGP which talks with the border routing gateway. You have a lot of complexity. You have also Midokura, which come with a solution like this. Yeah, the networking part is difficult. So at the beginning it was okay, the network is simple, we'll do that. They started on one part, but then they realized that if you want to have a serious infrastructure, then network is not so easy. It's not so trivial. Now, for example, there are plugins from the switch or routers which are managed via OpenStack, because if you have a machine which is on this host and then you make live migration and you go to another host, then at a physical level the traffic will flow to another port in the switch. So, and then this will happen automatically via OpenStack. Will say to the switch, okay, now here configure another mark that is allowed to go through it. So, this is.
How much time do you spend trying everything new out, or trying new things in OpenStack? Because all you tell us right now is that there are many options and you have to configure them, but how do you know which one is the best for you, for your use case? You have to try them all, or do you?
It depends. It depends. For example, now in the previous job, in the previous position that I had, the one that I built the story around it as a quality assurance engineer, my job was mainly testing application. It was not to build a cloud or something like that. And it was an effort at the beginning. Probably it was like 2-3 months. But then when I settled, I said, okay, this is what I need. Then I didn't spend any more time. I saw, okay, this is the network configuration that I need, this is what I need, okay, it works, so no problem. But it was a private cloud. It was, I don't know, probably when I left the company it was like 10 servers, 10 physical servers on which everything was working, and it was used by us. So and then everything just worked. We have just some Nagios probes that said, okay, we have low space on this, or otherwise. But if now in the job I am, yeah, I have to look, because we have to choose on Neutron what solution we want to choose. If we go vanilla, if we don't do vanilla. So I spend more time looking and going.
Okay.
If you go the route and use a private cloud, how
What?
much? If you use a private cloud, you're like you described it as testing setup. How much time do you actually spend maintaining it? And do you need to shut it down if there is a new major release of OpenStack, or is it all rolling and you can switch single components? Or
When I started with the Diablo version, it wasn't possible to upgrade. So I had to snapshot the important images, and then over the weekend to install the new version. Now, starting with the version that are now in place, Kilo, there is an upgrade path. So the controller, the controller which orchestrates everything can run on 2 or 3 versions. So you can upgrade the controller first, and then you can say, okay, he will speak with all the others which are in the other version, and then you can upgrade them one by one.
Oh, okay, but you need basically a standby admin all the time that takes care of the cloud. You can't simply install it and then use it for 2 years and then like, oh, you know, I need to upgrade it or change it. That doesn't work.
It really depends what you need for it.
Yeah.
The software is working, so if you install it for 2 years and you need it for testing and for your development, to have like 6 or 7 regression tests to run in parallel, it's okay, you don't need to touch it.
Okay.
But if you have much more people than you have some special applications with some special needs, so of course then you need somebody to take care of it. But I would start to think about it more like a Linux box. So you have a Linux box, you use it for testing, it works for 2 years, you didn't touch it, happy.
Okay.
However, OpenStack is not still into the Linux stability. It's far away from it.
No, it's not far away. It made a lot of progress.
Yeah, it made a lot of progress. Yeah, but for your use case, it would be perfect. Or if you have any problems, you can also come to us or to another OpenStack provider. Use the public cloud. Because, for example, if you do testing, you do not run the virtual machine for months, and probably it will be cheaper for you to go to the cloud provider and make your tests or run your application there than to have it private. So even if you take a look on the small companies across the Europe and US, there is a common use case that people are starting with the cloud, and then eventually they move to their private cloud.
If the business grow and
so big that you need your private cloud. So probably, to answer your question properly, go first for public cloud, see whether it works for you. If it works for you,
we have vSphere, the ESXi stuff, the free one, and it kind of works, but it's just
so when we upgrade, when you install and when you upgrade, probably not so often, no.
Somebody's taking care of this. Yeah.
Okay.
So it's constantly, it's just like, you know, it's not my task. I'm just wondering how the OpenStack compares to that.
No, I think it's comparable as administrative.
Okay.
And what's nice about OpenStack, you can fully automatize if you have a GitLab CI or Jenkins. You have so many APIs, so many tools around it that you can fully make it fly on its own.
We'll have a tech blog very soon about integration between Jenkins and OpenStack. Maybe if you're interested, you have to check, I don't know, in 1 week or something like that. There's someone who's working on it.
Are there some additional modules, for example, where you can just add applications to your virtual machines? For example, like standard application, a MediaWiki or Ruby installation or something like this? Just by click and it's there.
I think we had something.
Yeah, we had something like that. Do you know the Bitnami? You can
I know the Bitnami.
Yeah, so we had them.
But you have to do it manually, so you have to get the Bitnami sources and then you have to install it to this machine.
No, we had it as our platform. So I think still on some installations we have it, so you can just click 2 times and you have a WordPress running.
Okay.
But in our case, most of our customers were not interested in that, so probably we are going to remove it. Most probably. Unless you come and spawn like 20 per month, then we consider that. But currently what we see that people like to use them for testing, but they don't like to use them for the permanent platform. I don't know. On the other hand, Amazon is expanding the business in this direction, so I have mixed signals coming from this.
And for example, regarding your question, maybe an answer, maybe the field, the Mirantis, also they have a project called Murano, and then you have like packages. So then you have Hadoop, and then you say I want Hadoop with these many nodes, these flavors, this, push a button and then create for you all the instances and everything, and then you just push your data inside and then you take the result. So they have something. They have also Kubernetes. They announced recently that they put Kubernetes.
But this one they pushed to OpenStack 2 weeks ago. It's open source, yes.
So it's open source.
How's the price compared to a given cloud AWS or something else? At which point do you say it's going to be cheaper or more expensive at the beginning?
So, I mean, you have to take a look on the price and see, depending on the application. I think it's comparable. So in our case, I can tell about our case. So in our case, our price plus minus are comparable, but we have much better performance.
I think we're cheaper than Amazon.
Thank you, we're cheaper. Yeah. So so colleague says cheaper, we're cheaper. No, because it really depends how you come, in your setup. So my colleague is more working currently with this pricing stuff, so he knows better. But trying out in the beginning is just, I don't know, $10 max, and then you can try everything what we usually for 2 weeks.
Okay. But you do not provide Windows on this.
We provide also Windows on some of our deployments.
Okay. And how do you select where you get from it?
I think that if you ready, I don't have this information now, but if you give me your contact, I can put you in contact with someone in a company because there is some deployment where you need some licensing server or something, so it's not everywhere. But once you register, I think you can
select the deployment where you have Windows servers. We don't have, as colleague might said, we don't have them on all deployments because it's Windows licensing and so on. But we have given deployments here in Dresden, for example. In Neustadt, we have a big data center where you have Windows machines.
Okay.
How's the network bandwidth that you offer?
It depends on the deployment, so I would need to check it for you. But it's okay. It's sufficient. You should not worry about it.
I imagine if I install it in my home in the basement, I get like a VDSL.
No. We don't install our racks where there is VDSL. We have a black copper or
standing line.
We have that. Yeah, in some of the deployment we have 3 gig, in some of them we have 1 gig.
Okay. Alright.
So it's unless you would like to start some kind of DOS attack against some government, so then it might be not.
Not interested.
Yeah, I'm the government.
And it's your own network, or do you just?
We pay for network, so we are talking with the telecommunication provider, and we
you take different networks and different providers, or is it just one? And if it's falls out, or
it really depends on the installation. In many installations, we have from 2 providers. In some installations, we have 2 lines from 1 provider. It really depends on the installation.
But in general, you have mixed providers.
Yeah. Yes.
We would like to have just one. I think it would be easier.
Easier for you.
For businesses, of course.
And do you have deployments only in Germany or also in Europe?
Just in Germany for the moment.
How many cities?
I think we have around 20 deployments, not 20 cities. I think probably cities around 10, 12, something like that. Let's see, I think we have on the...
I think we're done.
How the response times, given the unpredictable location of the servers presently?
So in general, we are going to redirect you to 1 installation, so then you will have a good response times. So you would need to test, of course. I mean, this is the best way. As always, I mean, even if you go to Amazon, first thing what you do, you test performance.
I don't know, I saw some of the information. I can tell you, I can look at the monitoring, but I don't want to. I want to see if it's public or not.
Yes, to just fast. Hamburg, Hamm, Berlin, Dresden, Münster. Yeah. No, we're also thinking about these installations as numbers. That's why it's a hard question for us. We can say which number it is, but we cannot tell you, okay, where the city is.
So you're already cattling the cities.
Yes, yes. Otherwise, I mean, our minds would blow up. It's impossible to think about it. Okay.
Another detail about OpenStack, you have quite a high-level view on all the things. So, do you miss some low-level features for virtual machines, like different drivers for virtualization, for example? So, you have I have much experience with libvirt, and so you can have some not really virtualized drivers, but specialized, so you're not emulating special chipsets or something.
Victio or like
special word I will try this for network, for
for network, storage,
exactly.
display.
Do you miss some of those options, or do you just don't care?
No, we use them.
How do you use them?
You can configure when you configure the components, Nova Compute, then you can specify, there are parameters that you can specify, okay, I want to use this libvictio trial, something like that.
Okay. The last time I tried Openstack, it was such a huge system. It was really mind-blowing, so I could not get it up in 3 days, so it's too complicated.
Yeah, and it's going to be a little more complicated because you see how many partners are in this project, and of course everybody has their own business. So,
yeah.
So OpenStack is all about API, so API is the most important.
So the pain point getting it up the first time is if you have one part failing and you don't know which part is failing, and you have no experience how to debug every log file and everywhere.
I told you that. This is how I started.
And as Gabriel mentioned, that there are now installers, so you can go to SUSE, you can go to Mirantis, you can go to Red Hat, and have some kind of vanilla basic setup, or even to Ubuntu.
Yeah, try the Ubuntu one where they have also their own.
Sharp or?
Yeah, it's this extra system. It's not Charmus.
Mass.
This
Juju,
yeah, exactly. And it was a bit working, but not really, and so
I think that the best option is to start something like SUSE Cloud Studio or Fuel for Mirantis, and then you have, as my colleague said, you'll see, okay, this is a good Nova Conf. What is different than mine or something like that.
It's a good one.
This works. So.
From experience, so maybe 1 or 2 years back, it was they had default setups, but the default setup could not work on my system because I had some different requirements for the IP addresses and switches, so they could not leak out the MAC addresses of the virtual machines or something, and nobody wants to explain this problem in plain English. So
yeah, that's why there are a lot of companies who do consulting services. So
yeah, but then
it doesn't say
it's not fun anymore.
If you have a spare bugs on it. But I think it's good if somebody would like to start with maybe we can organize a second meetup. So there's also a component which is called DevStack. DevStack is a Vagrant-based environment that developers are using for testing stuff on their own machine. And this is also, for example, a good environment to learn about internals of OpenStack because you can touch everything and everything is working. And everything is working Vagrant box, so it's really handy.
You can break it from a working standpoint.
Yeah, and then you can recreate it and again and again and again.
And for example, in my case, it was very useful first time to install everything manually, step by step, each component, and then to understand.
That's what I feared. Because I use the script and it runs through like half of it, stopped, an error message, and I was lost. What is installed, what is not.
So if you guys are interested, we can make a hands-on experience next time.
Yeah, exactly.
Or have a hands-on experience on our cloud. I mean, we can have a free account and just deploy one of your applications just to play around. Because what is really nice is the API. I mean, I'm a developer. It's really nice to have like command line or this Python API that you can really embed it in your program. You can do everything pretty easy.
But the API are also available for Amazon.
Yeah,
and Africa, so it's nothing.
No, I know it's nothing special. I'm just saying
it's cool for the
it's
developer.
cool. I mean,
I would be interested in bringing 3 pizza boxes and then connecting them and get it running.
Okay, next time we can do it. We can do such a. If it's interesting, we can do such an event. Somebody comes with some servers, or we can use also servers on the cloud, and then we install components inside and see.
Yeah, Openstack and Openstack.
Yeah.
Open a wormhole inception.
Or we rent some Hetzner spot boxes, so you can rent them for 1 day and you pay only 1 day.
Yeah.
So you have real physical machines and the real challenge.
You don't have the virus in your hands. You
can't. There's not such a big.
But if you break them, you have to repair them. So it's not like a cloud box.
There's not so much difference between running OpenStack and OpenStack. I mean, of course, you have to configure KVM in a different way to use kernel, but it's the same. I mean, the same problems, the same.
Yeah, but the idea is that you can spawn an instance, then it is
then you can even spawn an instance.
But then you have the same. You spawn it.
Yes, that's true. Of course, you are not going to get this kind of hardware experience. Yes. I'm a developer. So.
Probably you are more sysadmin.
So I'm very happy if I don't need to touch dashboard, for example. I don't need to touch dashboard. I don't need to touch hardware. Then I'm happy. But of course I cannot avoid it because I'm working in Cloud&Heat, so I need to sometimes go and debug things, checking everything, memory consumption and so on.
Does this solve all issues with hardware outages, basically? So if you have like one server failing, or
this is a very important question because Gabriel showed you these diagrams when we are moving from the bad world of hosting everything yourself to the perfect world of software as a service, but it's not true because cloud provider is pushing all risk on you. So cloud provider, including us, say our virtual machines might work. Your virtual machine might work, but it can also crash. I mean, because this is the deal, we provide you a cheap community hardware for your virtual machines, but it might happen that they will fail. That is why when you develop application for cloud, you need to take care of high availability.
But that's why you have those auto-scaling groups and can configure it high available without any problems, right?
Yes, but
you get your SLA of 99.95 and for like $20 or so a month.
Yeah, but the software has to be developed specifically for the purpose. You can't just
it's
take
just
any software.
Regular clustered applications.
I know.
Have no state.
If I remember the outrage of Amazon, only Netflix survived. I think it's not biggest surprise because, for example, they build the cloud because they are aware. They build the cloud in such way, the application, because they are aware that one of the data centers can go away, and they cannot sue Amazon. That's why auto-scaling, everything sounds so nice, so sweet, but of course it means that you have to take care of it in your application budget. It's kind of what happened, okay.
That's what you always have to do if you have a highly available system, be it cloud or local.
Yes. But in the cloud it's like that sometimes from our experience was that the customers were coming to us and they were thinking like, okay, I have an application, I can just run it, nothing will happen. It's like, because they have this experience from their private cloud or private server, that they have a physical server, they manage it, they have this kind of trust in it, because it's like a real hardware, they spend a lot of money on it. But in the cloud it's different. I mean, even in Amazon, if you are unlucky and you are scheduled on the physical machine which is under heavy load, or you have some crazy guy streaming movies from the virtual machine, so it's like crash machine because it's so slow that it doesn't even matter.
We run our production load in the cloud and at Amazon, and we have never had any Such as we had once a hardware failure, but that has been like 3 years. Over more than 1,000 servers that launched. There was one hardware failure.
I will just bring it as an example. I mean, so for example, here in Dresden, there is an Amazon team that's exactly addressing these issues. How to make
performance isolation, which you don't do, right? You just give as much as possible, and if more load is on the server, you just give CPU shares according to what you purchased.
Yeah, we have a mapping between virtual CPUs and physical CPUs. So you are not going to get less than we promise you, but you might get more. With networking, it depends. But with CPU countries like that, with networking, we are moving to the new version of Openstack, which provides much stronger guarantees regarding networking. And in next version also, I think, hard disk. But we'll see.
Does OpenStack itself support migrating virtual machines from one location to another one? Or?
Inside of the same deployment, yes. So for example, if you define your deployment like OpenStack installation, you can say I want to migrate from this segment physical host to another physical host. You can do this.
But it's not live migration. So the machine is going to be pulled down.
No. I think it's. It's live migration.
I know that Little supports it under certain conditions.
Yeah,
you're right, Gabriel.
Shared storage and things like that. Yeah, it's live migration.
Yeah, Gabriel is right. Of course.
If libdict works, also
But it doesn't do like those fancy things that Google just announced, that it stores the packages and then replays them after the, like, to even get the 10 milliseconds it takes to swap over the 1 second.
Next release.
next. And things like that, VMware are possible.
And will OpenStack has a roadmap to scale to different data centers, or do you have to work around it for yourself?
Currently there is now a concept of cells, so you can compose your logical data centers of many data centers under it. So there is a new version.
I think 7 has something like that because they have 2 big data centers, one in Budapest, one in Switzerland, where they're located, and they have like this concept of cells, and they have high speed connection between those 2 data centers, and it's
okay.
More questions left? Which stack does OpenStack use? I think Python and Angular JS, right?
Python.
And the dashboard is in Angular?
Django.
And which version? 2.7?
I will need to check. But now they are planning to move to Node.js. Node.js.
Oh. For everything or just for the founding?
Dashboard.
Oh,
It would be nice to everything.
Let's start over again.
It's quite nice that it's in Python because Python is easy to read. So, for example, OpenStack CLI you can misuse to write your own scripts, but documentation is pretty poor. But you can always go to the code and read it. It's like a book. It's really nicely formatted. It's really nice that it's in Python. From readability point of view.
What do you think? Should be another meeting with something like installing? Or is it interesting? Or?
I think we should raise hands. So like a
I'm
setup
interested.
meeting or something? So,
Then we can organize something like that.
yeah, we'll just stay in contact on it. Maybe not the next month, but yeah, just get it going.
And we can start also with their stack first and then go to hardware.
Yeah. Because I think it's a really good starting point to see where to begin. Maybe even installing it by ourselves.
Yep.
Awesome. Do we have questions left now?
Thank you again. Okay, we have our occasional beer shower, so if you want to join us, we'll be there.